Fluid power is based on natural principles as old as time. Harnessed as a science and applied as a technology, fluid power is a vital part of our lives, from the work we do to the entertainment we enjoy. By itself, fluid has no power, but when confined and placed under pressure, fluid can transmit power, power that can be stored, directed, and made to do work. If you're discovering fluid power for the first time, you may be surprised how hydraulics and pneumatics work in your world. Look carefully, and you'll see how fluid power is working all around you. The basic physical principles which explain the special characteristics of fluid power have real-world applications, helping make businesses more profitable and our lives safer and more convenient. Fluid power systems amplify power, transmit power, and control power. Fluid power enables us to extend our reach and increase the power of our grasp. On a backhoe, fluid power controls and powers the bucket, lifts the boom, extends the load, and stabilizes the machine under changing loads. Fluid power is also versatile. It's as useful for heavy lifting as it is for delicate handling. And fluid power allows for many kinds of motion, including very fast lateral and spinning movements, as well as extremely precise pick or place movements. To really understand fluid power, we have to understand the many ways fluid can be used to transmit power or control and multiply force. Fluid power is a pressurized liquid or gas in a closed system. The liquid or gas is controlled and directed through hoses or tubing from a source to valves and actuators. An operator interface harnesses the ability of this power to work by transferring it at will to a cylinder or motor which does the job. The power of pressurized oil or other liquid is hydraulic power. The power of pressurized air or other gases is pneumatic power. Both behave similarly under pressure. Here's how. A pump or compressor moves the liquid or gas through the system to an actuator, which converts pressure into linear or rotary force in motion. Let's look at fluid power another way. Imagine a mouse trying to lift an elephant. According to laws of physics, the mouse could accomplish this seemingly impossible task if he had a lever long enough to create the mechanical advantage. That would be a very long lever. But if we taught the mouse to apply fluid power principles, the task would be easy. That's the really exciting thing about fluid power. Fluid power systems multiply and direct force. With properly sized pistons, force is multiplied on the larger piston even though the fluid pressure is equal on both. In other words, the greater the diameter of the piston, the greater the force. Let's take a closer look at how this principle works in your world. Consider the roads you travel every day. They were built with the help of hydraulically powered earth-moving machines used to haul countless tons of dirt and gravel. Think how long it would take to build these roads with muscle power alone. Fluid power enables a driver to steer a race car almost effortlessly. But you don't need to be a race car driver to enjoy the benefits of fluid power. It's at work in the power steering system of your family car, too. In simplest terms, all power steering systems use hydraulic pressure provided by the power steering pump to amplify the force the driver applies to the steering wheel. When the engine is started, the pump puts the fluid under pressure. When the steering wheel is turned to the right, the control valve senses the direction of rotation and channels pressurized fluid to the right side of the power cylinder. The resulting motion is transferred to the vehicle's wheels, augmenting the mechanical force applied to the wheels by the driver. A corresponding effect takes place when the steering wheel is turned to the left. When the wheel is centered, pressure is equal on both sides of the cylinder. And that's not all that fluid power helps steer. A pilot changes course by activating fluid-powered devices to move the plane's control surfaces against massive air resistance while traveling hundreds of miles an hour. Fluid power is easy to understand and simple to apply. Only a small number of components are needed in our basic fluid power tool chest. It's the different combinations and the variety of these devices together with the levers, rods, pulleys, and chains that they're connected to that allow fluid power to provide a myriad of solutions. Most people are unaware that fluid power is so widely used, but this technology is well known to the people whose job it is to move things, pump things, dig things, transport things, haul things, and lift things. Now that you know what to look for, let's explore some additional applications that you can model. We'll start with the sliding door familiar to all of us. See how the door powered by pneumatics eases entry? Many sliding doors take advantage of a simple fluid power system. An electric eye senses motion and energizes a valve. That valve routes compressed air to the cylinders, causing the pistons to retract, and when they do, the door opens. On a metal press like this one, hydraulic pressure applied through pistons shapes metal. As the pistons extend, the metal is shaped. When the pistons retract, the metal is removed and a new piece is inserted. Although a gum wrapper is only a thin piece of metal foil, our model performs the same actions as the bending press and demonstrates the same fluid power principles. The operator of a forge press effortlessly wields massive hammers to shape the hot steel through hydraulic cylinders that are controlled by a computer. Fluid power is at work in most warehouses. This lift lessens the work of transferring loads to and from storage locations. The scissors mechanism keeps the platform level, which ensures operator safety and prevents damage to the material. Hydraulic fluid is pumped into a cylinder, raising the load. Larger pistons and greater pressure can lift heavier loads. Note how the platform remains level as our model raises and lowers. The valve permits the pressure to be channeled to the opposite end of the cylinder, retracting the lift. Lifts are invaluable safety aids in many professions. Fluid power moves with precision, even in the most delicate situations. An operator can easily use the hand pump and valve to aid in lifting. Releasing the valve allows gravity and smooth hydraulic control to carefully lower the load. Our model is pneumatically powered. A second cylinder and piston were added to allow for rotation. In an automotive assembly plant, hydraulically powered and controlled robotics precisely weld hundreds of points quickly and accurately without the hazards common before this technology was implemented. Fluid power animates sophisticated robotics, which do a multitude of tasks, such as delicately placing a fragile windshield into a car body. This multi-axis movement and rotary motion makes robotic automation possible. A simple gear system shown in this animation converts linear to rotary motion. In our pneumatic model, it's a lever that converts linear to rotary motion. Results of fluid power at work, which often seem magical, are really examples of textbook physics. Speaking of magic, did you know that many of the movie creatures that scare and delight us are brought to life by fluid power? These monstrous jaws and forelegs are powered by hydraulic cylinders clothed with a lifelike rubberized skin. Without the subtle control of fluid power devices, it would be much harder for special effects experts to bring these creatures to life. Our model shows a simplified view of the internal mechanisms at work. Back to reality. Some people only discover fluid power when it comes to their rescue. Because fluid power is the heart of one of the most important life-saving devices ever invented, the jaws of life. With the right mechanical attachments, this innovative tool can cut or spread metal easily due to the multiplication of forces. Whenever people are saved from the wreckage of a crashed auto with help from this amazing machine, they have fluid power to thank. This video exploration of fluid power is over, but your discoveries are just beginning. If you have an inquiring mind and like to solve problems, you owe it to yourself to explore the possibilities of fluid power. When you do, you'll join the ranks of thousands of technicians, designers, and engineers who apply this versatile technology as they seek more reliable, efficient, and productive ways to work and play in our world.